Hey guys, in this video we'll be going over how to solve first-order linear differential equations using a method called integrating factors. So how do you know when to use this method? You need to look at the problem you're given and find clues. The method of integrating factors is only used for first-order linear differential equations, so like the name suggests, the order has to be 1 and the equation has to be linear. So here I have a couple of differential equations, and we're going to identify which of these are good candidates for this method. In the first example, we see y prime. There's no y double prime, and there's no y triple prime. Therefore, the highest order is 1. We now have to see if this equation is linear. So we check to see if there's any products between y of t and y prime, which there isn't because they're being subtracted. Therefore, this equation is linear and first order and is a good candidate. For the second equation, we see a y double prime. We automatically know that this is a second order equation and will not work with an integrating factor. In the third equation, we see a dy over dt. Don't get scared when you see this. Dy over dt is the exact same thing as y prime. So we know it's first order. Now we need to know, is it linear? Y prime and y of t are by themselves, therefore this differential equation is linear. When you're taking an exam or quiz, the professor most likely won't tell you what method to use or what type of differential equation the problem is, so you need to be able to identify that quickly so you waste less time figuring out how to solve the problem. Another clue to know if this method is the right one to use is to see if your problem matches the general format of a first-order linear differential equation. The general format is y prime of t plus p of t times y of t equals g of t. The goal of a problem with this format, like any other differential equation, is to find y of t, the solution. There's two ways to find y of t. Method 1 is to go through all of these steps and derive a formula, and method 2 is to memorize the formula and just plug and chug into the equation. Here's the first method. You multiply both sides of the equation by the integrating factor. The integrating factor basically simplifies the problem and allows you to find y of t easily. The integrating factor is a quantity, e raised to the integral of p of t dt. So let's multiply both sides of this general form. We can simplify this line by substituting p of t I of t with I prime of t. So I of t equals e raised to the integral of p of t dt. The outside function is e to the t, and the inside function is the integral of p of t dt. Using the chain rule, we take the derivative of the outside function, and we keep the inside function the same, and you multiply this quantity by the derivative of the inside function. The derivative of the integral of p of t dt is just p of t, and e to the integral of p of t is just I of t. Therefore, I prime of t is I of t times p of t. Now I hope you noticed that we have the product rule here. There's two different functions, and we see both of the derivatives, and they're added together. We can undo this product rule to get the derivative of the quantity I of t times y of t. We now integrate both sides and can isolate y of t. So y of t equals the integral of I of t times g of t dt all over I of t. Instead of going through all of these steps, you can use method 2, simply memorizing this equation and plugging in your values. But there's only one tricky part I want to point out. Let's say in the problem you're given y prime of t has a constant in front of it, or there's a function, let's say k. Before you can identify your p of t and g of t, you must isolate this y prime of t by dividing the entire equation by that coefficient k. P of t is now equivalent to p of t over k, and g of t is equal to g of t over k. Our new integrating factor is I equals e raised to the integral of p of t over k. In the next video, we'll solve a problem using both of these methods.